So it's my second video of transportation problem. I have already told you that you have to find out two solution here. One is optimal solution and the another one is basic feasible solution. So to find the basic feasible solution, there are mainly three rules. Okay, I have already discussed about northwest corner rule and it is the second rule, that is least cost or matrix minima method. Okay, so least cost or matrix minima method, so it's named least cost, so it means in the table, in the given table, you have to find out the least cost. Okay, so I am drawing a table, then I will discuss what is the problem and how you can find the solution. Okay, so let me draw it. I have taken a very simple example. Okay, so here you will see that there are supply and demand. Okay, so if the summation of supply and the summation of demand, that is same, then we can say that it is a balanced kind of problem. Okay, and in case if the supply is greater than the demand, then we have to draw a dummy column, and if the demand is greater than the supply, then we have to draw a dummy row. Okay, so from this given table we have to find what is the minimum, value in the given table. Okay, so we can see that 0 is the minimum. Okay, so here are two zeros. Okay, so we can take any of these two zeros. Okay, so let's take this one. Okay, so the supply is 8 and the demand is 6. Okay, so in between 8 and 6, what is minimum? 6 is minimum, so we will take 6 here. Okay, and after taking 6 we will make it 0, and we will do 8 minus 6, so it will be 2. Okay, so as we are getting a 0 here, so that means we have to delete the whole column. Okay, so this column will be deleted. Okay, now find what is the minimum element from the given table. So again we can see that 0 is the minimum, so 0. So here in between 4 and 10, what is minimum? So you can clearly see that 4 is the minimum, so we will take 4 and we will make it 0, and 10 minus 4, it will be 6. Okay, so as it is 0, that means this column also will be deleted. Okay, so I am deleting this column. So again, in between 2 2 3 2 3 and 2, what is minimum? So 2 is the minimum, so we can take any of this 3 2. So let's take these two. Okay, so okay, in between 6 and 8, what is minimum? 6 is minimum, so I am taking 6, and so that is that 6 will be 0, and 8 minus 6, it will be 2. Okay, so as this is 0, so we will delete this whole row. Okay, this row will be deleted. So in between 2 3 3 2, what is minimum? 2 is minimum, so I am taking any of this 2, so I am taking these two. So here I am getting 2, and here also 2, so we can take any of this. So I am taking 2, so it will be 0, and it will also be 0, and so as it is 0, so we will delete this whole, row, and here I am getting 0, so I will delete this whole column. Okay, so here is only 2, so the cost is we can take any of these 6, so 6, and it will be 0, it will be 0. Okay, so let's count the cost. Okay, so the cost is 6 into 2 plus 2 into 2 plus 4 into 0 plus 6 into 2. Okay, the cost is 28, and the total number of occupied cells is 1 2 3 4 5, so 5 occupied cells are 5, and 5 is less than equals to uh, 1 2 3, and here is 4, so 4 plus 3 7 means m plus n minus 1. So here we will get a degenerate solution. Okay, we will get a degenerate solution. So like this you can solve any balanced transportation problem using least cost or matrix minima method. Okay, thank you.